Hi, this is Vijay. In this particular session, I'm going to talk about the Vxlan theory part, as well as we are going to demonstrate the Vxlan data play learning lab. And let's just start with the Vxlan. What exactly is the Vxlan? What is the purpose of using Vxlan? Why we are using Vxlan? Okay, Vxlan is a overlay protocol. The full form of Vxlan is virtually extensible local area network. It's an open standard protocols. So when initially industry came up with the Vxlan concept, the Vxlan was mainly designed for to avoid the or get the scalability in the large infrastructure such as ISP and cloud providers. And as the name implies here, Vxlan virtual extension is a layer 2 protocols and which works across the layer 3 network infrastructure. Vxlan encapsulate the layer 2 Ethernet frame inside the Vxlan uh, packet that includes the IP address. Vxlan segment are identified by the 25-bit BNID and field, whereas it can be up to 16 million segmentation. And Vxlan is a centralized specification created by the collaboration of VMware, Cisco, Arista network, and Vxlan is definitely has a different or unique RFC. So this is the RFC page here. So it's published on 2014, and I will highly recommend you guys to go and check and have a look on this IFC part. And a lot of things has been provided in this, and you will thrill to read this document. Okay, so let's sorry, let's go on the what what exactly is the VLAN, right? And what exactly is the VXLAN? Why we need VXLAN when we have the VLAN, right? Let's take a comparison here between the VXLAN and VLAN. VXLAN is a similar to most probably, I would not say more similar, but yeah, it's similar to the VLAN. Also, it encapsulates the L2 frame and segmentation network just like the VLAN. The main difference is that VLAN use the tag on the L2 frame for encapsulation, and it can only scale up to the 4000 VLAN, right? Whereas VXLAN encapsulate the MAC in a UTP header and is capable of scaling up to 16 million segmentation. So there you will see the huge difference. It's 4000 whereas 16 million, right? There is no comparison. And what exactly and the advantage is VXLAN adding in our infrastructure, right? So VXLAN definitely there has been a large infrastructure, large service provider, large cloud environment where a VXLAN has been deployed. And what exactly the VXLAN is providing us in the infrastructure, right? The major thing is scalability and flexibility. The VXLAN improve the scalability in the network or virtualized data center. It also makes it fabric more flexible. The number of VLAN layer 2 identifier are drastically increasing from 2000, 4,000 to 16 million, which is exceptional, right? And second thing is segmentation and multi-tenancy support. So VXLAN provides a high level of security by segmenting the network. VXLAN traffic is limited to VNI. So it's totally isolated, right? So the segmentation can also help in multi-tenancy architecture where a single infrastructure must be shared. Okay, and layer 2 simplification, that's a third advantage. So simplify the network and reduce the need of layer 2 spanning tree, right? The moment you enable the VXLAN itself eliminates your spanning tree requirement because VXLAN is an overlay protocol. It works based on top of the underlay protocol. So if you talk about underlay protocol means IGP protocol. It's a routing protocol where you enable the routing protocols, you automatically eliminating the L2 networking there. L2 networking, this is STP, spanning tree protocols. Okay. Fourth advantage adding VXLAN is to allow IP mobility. So definitely, if you have the vMOS kind of stuff in your infrastructure and you really want some kind of solution which will not you do not want to any kind of consideration or anything, you just always go ahead with the IP mobility, which can make your life very easier. Because the thing is, we have 4,000 segmentation in VLAN, right? And you want to, suppose you are wanting to move one data center VM to another data center. You will have to make sure that that VLAN information should not be overlap, or IP segmentation should not be overlap, right? Whereas in VXLAN, we have 16 million option, right? It can create multiple times with the multiple VNIs. And the fifth advantage is layer 2 and layer 3 connectivity. A virtual layer 2 running VNI is a buildup of layer 3 infrastructure. So VXLAN switch encapsulate the frame into the layer 3 packet. Okay. So all the layer 2, layer 3 will be run together when you're going to run the VXLAN. And also it is a it is more compatible over the software defined network. So VXLAN decouple the central network controller, okay, from the data plane to centralized controller. So it has flexibility because since it's an overlay protocol, it really do not really control over the hardware, or it really do not care about the control plane, data plane decouples in decoupled in infrastructure. As long as you have the environment where you support the capability of the VXLAN, it really smoothly can be worked. For example, Vxlan is an overlay. It support the Vxlan, for example, support the overlay of open vSwitch, right? Just like VMware vSwitch. So, and also that in the seventh advantage is hardware support. Although it's more common to run Vxlan in software, and some platform implement it in a hardware though ASIC through ASIC. Just for example, Cisco 9K, right? Cisco 9K, if you're going to run the ACI with the Cisco 9K mode, you will automatically get the VXLAN inbuilt, right? You do not have to configure anything related to VXLAN. And whereas hardware, other ASICs such as Cisco Catalyst, Aruba, Dell, you name it. So the switches which have no ASIC specification, or which programmability for the VXLAN, you have to enable the VXLAN manually. Okay, and this only support for the VXLAN ACI. ACI has inbuilt feature with the VXLAN. Okay, and there is also there is no any kind of restriction, because since it's an open standard protocol, it can support on any vendor, right? And let's go for the VXLAN overlay network design option. What is the overlay exactly? Okay, so overlay services, what it provides the layer 2, layer 3 connectivity between the source and destination, right? And it provides the channel encapsulation. It provides the underlay transport network. So, and second thing is control plane data plane. What actually role of the VXLAN in control plane data plane, right? Why we need that? So control plane is required for peer discovery and route learning, route distribution, remote learning, local learning. Suppose you have two sites, right? Site one, site two. If you do not have the underlay or control plane connectivity using the protocols, how are you going to achieve that peer discovery, right? And in the data plane is again is a necessary to have data plane protocols running to support the non-unicast multicast traffic, especially the increased replication unicast and multicast. Okay. Now VXLAN is the overlay encapsulation technology. Okay. It creates the virtual network overlay on top of the existing physical network infrastructure. Okay, it uses the underlay IP address and build the flexible layer to overlay logically network on top of it. Okay, so you do not need to worry about anything. You just suppose underlay protocol, you name it IGP protocol, right? You run this OSPF or EIGRP or BG, you name it, right? As an underlay. On top of underlay, you just run the VXLAN, because VXLAN does not work based on the control plane data plane, you must have the control plane data plane. Then only Vxlan can run on top of it. It's a tunneling solution. It's an overlay solution. You must have the infrastructure as ready in order to support the Vxlan. Okay. There are many more advantages to using the overlay network. The most obvious one is its segmentation. So you can have the multiple virtual tunnel as much as you want. Okay, the overlay and underlay network are totally independent. So there is if there is any changes in underlay network topology, the overlay network will not be affected for sure, because overlay has its own mechanism to work, right? There is no interdependency. The overlay network can be redesigned without needing to add, remove, update network devices. Okay, and physical problem, if there is any physical problem in infrastructure, if I say that underlay and overlay is totally independent, but make sure that your physical infrastructure should be up and running, and then only overlay and underlay will work, of course, right? If there is any like enough bandwidth or something like it happen, definitely Vxlan can be impacted, because Vxlan is not something is it never die solution. It will be impacted if you have the issue with the physical environment. Okay, let's go with the leaf and spine architecture. Okay, so leaf spine architecture is mainly uh, uh, recommended for the infrastructure nowadays. Okay, it's because two tier architecture, the best way, and it provide also the guarantee scalability and flexibility on the Vxlan overlay, while allowing the underlay to make the changes. So Vxlan, again, using the Vxlan on top of the leaf and spine architecture, will be adding you the uh, better infrastructure experience, I would say. Okay. And between the leaf and spine, you have to run the underlay. So make sure that before running the underlay, you must have the leaf and spine up and running with the underlay protocol. Okay. So leaf and spine is an independent architecture. It's not totally like designed for VXLAN, right? Apart from VXLAN, if you suppose you do not want to VXLAN in leaf and spine architecture, you do not have to run it, right? It's just an architecture to represent the DC and to make the DC experience better than the three-tier architecture. Okay, so this is the underlay. Suppose you have the leaf and spine, and make sure the leaf and spine running fine, everything is running fine. Then second thing is you have to just establish the overlay protocol in order to run the VXLAN. Okay, so overlay protocol, just like the you can say name the VPN, right? VPN is L3 protocol, right? Where in VXLAN is a pure native layer 2 protocol. In order to support the layer 3 mechanism, it needs the some external protocol we call the eVPN. Okay, if the moment you enable the eVPN, it provides you the L2 DCI extension. Suppose you have one site sitting in Chicago, another site sitting in New York, right? You need some type of mechanism to interact or extend your L2 VLAN. Previously, we had in data center, we had OTV, overlay tunneling virtualization. Now we have a VXLAN, which is more scalable, much more flexible, or it provides the mobility, better mobility compared to the OTV, right? Let's talk about the leaf and spine uses tool here. Okay, so spine switch is only used for the bypassing the traffic, just passing through the traffic. It does not require any kind of VXLAN configuration. Okay, so you can say spine is the switch is the one who just hand over the traffic from source to destination without caring about what is inside, what is running inside it. Okay, as long as it has visibility, it can provide you. Whereas leaf switches provides the it connect independently with the or interconnect with the spine switches, as well as the leaf switches also creates the VXLAN tunnel encapsulation. Okay, so all the VXLAN translation with the VLAN on the tunnel creation, all things encapsulation, including decapsulation, will be happen on the leaf switches. Okay, so leaf switches is a wholesale for you to run the Vxlan. All the leaf have a link with every spine switches. Of course, you have to have the connectivity with the core switches. Every link between leaf and switch is a routed through the IP address by IGP protocol. So between leaf and spine switches, interface going to be L3 interface. There is no L2 interface, and it must be the must running the any of the IGP protocol. Okay. This topology makes every destination only two hop away, right? So unlike the layer 3 or tier 3 network design, the tier 2 leaf and spine architecture provides you better hop count here, because everything, whether source destination, source is sitting in different room or destination is sitting different room or source is sitting in different area or destination is sitting in different area, as long as you have leaf and spine architecture, everything going to be in two hop away. Okay, first hop is spine leaf switch, second is spine switch, and spine switch will directly forward your destination packet to leaf switch. So everything is two hop away. Okay. So here is sleep and spine fabric topology is highly relevant to the Vxlan, because overlay network scales supporting the underlay can be physically grow and decrease and increase. So just like auto scale concept, so Vxlan will not be impacted if you have, suppose currently you have 10 devices, right? And in future you want to increase your physical infrastructure to 20, right? You do not have to worry about especially for the Vxlan. Vxlan will be auto heal, and you just increase the infrastructure expansion, and it will automatically sync with your infrastructure in case you are using the ACI. But in case if you are using the legacy network, legacy in the sense normal NX2X mode, catalyst mode, of course you have to do it manually configuration. So as I said that as your network scales, you do not have to change your design, right? It can be remain same, and your all the existing infrastructure keep up. So let's talk about the Vxlan encapsulation. So we know that so far Vxlan stressed the layer 2 subnet across the layer 3 network limit. It built the logical overlay on top of the switching fabric like leaf and spine underlay switches. And to make this work, Vxlan encapsulation layer 2 Ethernet framework, Vxlan packet that also encapsulate the UDP and UDP and IP. Okay, so let's take the encapsulation type here, right? Think Vxlan packet has size of 50 byte. Okay, so if any packet is coming from outside or inside, your packet will be encapsulated. Okay, so Vxlan is not protocol which will initiate the traffic. Okay, you must have the traffic from the any environment. The moment traffic will hit to the leaf switch will check the VLAN to VXLAN mapping, and it will immediately encapsulate packets based on these details. So you have the like 14 byte of source and destination MAC address, VLAN ID. These are the legacy network ID, and you have 20 byte of the IP header, which is going to be the leaf uh, VXLAN source address, VXLAN destination address. You can say leaf 1 or leaf 2, for example. You have where you have the UDP header. In the UDP header, you're gonna have the source. In UDP header, you have the VNID, VXLAN ID. You have UDP port ETU 4700 something, and VXLAN definitely actual header going to be the 8 byte, where your VXLAN ID going to be present, which field going to be 24 bit. Okay, then you're gonna have original L2 frame, which coming from the source itself. Okay, these are the just again total 50 byte of the traffic, or 50 byte of the uh, frame or encapsulation at when any L2 L3 traffic hit on the VXLAN leaf switches. Okay, there are multiple fields here, which you can probably go through one by one. What is the meaning of outer MAC? What is the meaning of outer IP? So outer MAC, this header contains the information for the next hop transport. It includes the destination and source MAC address of Vxlan endpoint. Okay, a VLAN ID is 16 bit, and the size of the outer MAC address is 14 byte. The outer IP header is this header uh, uh, allows the transport across the IP address. It includes the source destination IP of the VXLAN endpoint. The size is going to be 20 byte. Okay. Then you have outer UDP header. This header identifies the packet as a VXLAN differently, and it contains the UDP source port and VXLAN port, and UDP length size going to be 8 byte. And then we have finally fourth header is Vxlan header. This header also referred to the VN ID. It's again you VLAN to Vxlan ID, which I will the moment you convert your VLAN to VN ID, that VN ID information flag will be inside this header. Then you have inner MAC address. Inner MAC address means that's original packet which is coming from VLAN, okay, not from Vxlan. Okay, so let's talk about what exactly is the VTAP here. Okay, any endpoint host a router, suppose the VXLAN, can refer as a VTAP. Okay, it can be physical or it can be virtual. VTAP job is to create the tunnel and decapsulate the VXLAN traffic. How does it work? Okay, suppose you have host A, host B. Okay, when host A want to talk to host B, it send your packet to the next hop, which is the leaf 1. And leaf 1 is running a VXLAN. And for VXLAN, you have to create the tap address. It means you have to create the tunnel where VXLAN, if any VXLAN traffic will come there, it will automatically generate the traffic. Okay, and encapsulate the traffic, rather, I would say. And then it will go for the next hop. Then it will go for the next hop. The next hop next door device going to be spine. Spine will check the multicast address because in a VXLAN there is no such called the broadcast. Everything going to be the multicast traffic. Okay. When I say multicast traffic here, let me explore more of it. Suppose you have this source. Okay. Different color. This is the spine switch. Spine switch. Okay. This is the leaf 1. This is the leaf 2. Sorry, leaf 2. This one. Suppose if this traffic is hitting here and encapsulated in a VXLAN, okay, VXLAN. The, the problem is this the source or destination will not be known to each other, right? How this source will know about this destination? It will be unknown, right? To avoid the broadcast, because if we do not tell this device if you have packet reach to this particular destination, it can flood to everywhere, right? Which is not good sign for your infrastructure. In order to achieve that, we have come up with the mcast, multicast concept here. It means we creating the randomness point. We are creating one proxy device. The proxy device is will be spine switch, spine, spine switches. Okay. Then you're going to have the leaf switches. Then you're going to have these switches. If any traffic is coming here, we are going to tell this switch, okay, if you don't know anything or you know anything, all the traffic must be registered under the randomness point, this proxy server. And this proxy server, we call that multicast randomness point. Okay, so if suppose you have 20 switches which are running the VXLAN, they must register all the details in the randomness point device to the proxy device. If any traffic is coming here to there, if suppose this source and destination is not there, this switch has a responsibility or database to identify the destination for the traffic. And this device will take the decision or to call for the any unknown traffic. traffic. The main purpose of using the multicast randomized point is to avoid any kind of flooding and make that Vxlan packet experience much better than the using the broadcast. Okay, let's go into the practical part now. Okay, so Vxlan is two types of Vxlan. One is the L2 Vxlan, that is flood and learn. We call the data plane Vxlan. Second is L3 Vxlan. We call that multi-site Vxlan also. So where you have to run MPBGP EBPN concept. Okay, and that is only recommended when you have the layer 3 infrastructure, multiple sites are running all together. Okay, so let's me go to here. So let me explain first what exactly we are trying to achieve here. Okay, so we have two sources, which are we have three sources in fact. One is in here. This is the client. This is the server, and this is the also client. This is also client PC2. This is suppose data center application server. We have client from outside. We have client which are sitting inside the legacy network, and this is the new network, for example. Okay. Now they all are participating in the VLAN 100, 1000. Okay. Now VLAN 1000, what I'm saying that VLAN 1000, I'm going to convert this VLAN to Vxlan 5001. Okay. 5001. Similar way for this one also. So they are in the same segment. They can talk to each other without any interruption. Okay. Using the Vxlan encapsulation. The moment packet will initiate here, here going to be the tunnel. Vxlan tunnel, which will form between them. It will form between them. Okay, once the traffic will hit to the tunnel, tunnel will do the encapsulation. Then after encapsulation, packet will go to the RP. Then RP will identify, okay, this host or destination belongs to this. It will send to this IP address. This host, then decapsulation will happen to this on this destination switch. Okay. So if I say that, what exactly is a prerequisite? So I have already configured these devices. Okay. So first step is let's go step by step. Excuse me. This is the lab. Okay. So this is the lab. The first thing is we have created the three loopback address on each devices. Each devices we have one loopback address. The purpose of loopback address, there's two things here we can use. One loopback purpose is to have this loopback as a Vxlan source on the leaf switches. On the leaf switches, the purpose of loopback is to have as a source address. You can you can use source address as a physical interface or SBI anything. Okay, but the concept or the recommended way to use the loopback address. The reason we have loopback address on the spine switch to configure the randomness point, to configure the RP for the multicast. Okay. So each once you configure the spine switch as a RP, we have to tell each switches go and use that randomness point for any communication. Okay. So all the loopback going to be the /32. Okay. If I shift this /32. Then second thing is we have to do the physical addressing. So we have done that. We have on the spine switch, we have two interface. Okay. One interface going towards the leaf switch 1, second interface towards the leaf switch 2. Leaf switch 1 has the 192.168 1.1, 1.0 subnet. And in the leaf switch 2, we have 2.0 subnet. 2.0 subnet. Okay. Once the leaf interface is configured, you have to configure the Ospf feature. These are the two features which are required on all the switches, whether it's a leaf or a spine switch. Okay, so if I go here to our spine switch, we have IP interface brief. We have three IP addresses. Okay, one is the loopback 30.1.1, which is randomness point. We have 192.1.0 subnet, which is going towards this leaf 1, and this is going towards the leaf 2. Similar way, if I go to the leaf 2 one here, so IP interface brief, we have three interface. Sorry, so let me remove that. Okay. So IP interface brief, we have two interface. One is the loopback, which will act as a source address for the Vxlan kernel. Second, we have the IP address, which is directly connected to the spine switch. Okay, towards the spine switch 1/1. Similar way in a leaf 2, we have the IP interface brief. Okay, we have same way, we have loopback address, we have the interface address. Now, once you have these two address, you have to run the OSPF between them. So between the leaf and spine switches, we have to create the underlay. We have to create the underlay protocol. It can be BGP or any dynamic routing protocol. You have to create the underlay. So this interface will belong to the OSPF one. Sorry, OSPF area 0. Okay, so this all three interface will belong to the OSPF area 0. If I go there and check that, these all interface are configured the OSPF 0. Okay, so this is pretty much simple configuration. You have to just enable the feature OSPF on all the leaf and spine switches. Okay, then you have to, sorry, then you have to call this. We have to create the process ID like the router OSPF 1, for example. And you have to call this all the interface under the OSPF area 0. Okay, if I show you that in the spine switch here, so run OSPF, you will see that we have feature OSPF, we have OSPF router OSPF 1, then we had called this all the interface under the OSPF 0, area 0. Similarly, if I go to the leaf 1 here, so run OSPF, leaf 1 has the same. We have enabled the feature, we have called these interfaces under that. Okay, for the leaf 2 also, we have the same. So run OSPF, we have enabled the feature and we have created the process ID, we have this interface. Now, if I check that OSPF, so IP OSPF neighbor, we have neighbor, leaf 2 has one neighbor, which is towards the spine switch area. Leaf 2 have one neighborship with the spine switch here. Okay, all the networks are point to point. So that's why we do not have DR here. Okay. And if I check to the leaf 1, it should have the neighborship with the spine switch again, spine switch. Now, if I go to the spine switch should have two neighbors. One with the leaf 1, one is the leaf 2, right? It has two neighbors. One with the leaf 1 address, loopback address, leaf 2 loopback address. Okay. Now, if I go to the third step now, the third step, you have to enable the multicast feature. You have to enable the multicast feature. Okay, the spine switch we configure as a randomized point proxy, as a proxy device. Okay, so on a spine switch, what we are going to say, you are the you are the proxy server, and make sure that you are responsible for if any client want to come and join you, they should come using this group IP. Okay, if I go to this group IP, go to the Ipv4 calculator, so all this segment which belongs to this, if I calculate here, so we have this much subnet. It means 224 to 22239. So if suppose client is coming from 228, 227, 226 using as a source address, definitely they will able to join because we are covering all these IP addresses in the spine or in the multicast. Okay, we are saying that okay, use this. SSM is really not required, but I'm using as an alternative, and all the interfaces on the spine switch. All the interfaces on the spine switch. I'm going to say okay, run this enable the multicast, saying that IPPM is pass mode. So Nexus switches does not support the dense mode due to the flooding. This strange behavior of the PIM dense mode, because dense mode has issue with the flooding, and whereas sparse mode only send traffic if you are interface is running the multicast. Okay, this is the this spine configuration. You have to just run the two things. If I go to the spine switches, so run pip, you'll see that we have this command. So 30.1.1 is our loopback address. I'm saying that IP PIM, this is the loopback address, which is your local. You're going to be the PIM, and this all the interface will also run the multicast traffic. It means this interface, I'm enabling the multicast feature and saying that this interface, okay, you are capable to handle the multicast traffic. Similar way, if I go to the leaf one, so run PIM, okay, I'm saying that, okay, this is your MAC, this is your client, proxy client, and this is your group ID. From this group, you are going to join. I'm going to run the PIM mode. If I how to say that, so IP PIM. So IP PIM RP. If I say so IP PIM RP, in the leaf switch, the moment you configure that, you will see that RP address is this one, right? RP address is this one, priority is this one, and this is the group address. If I go to the same to the leaf switch here, so run PIM, same command we have run, so IP PIM RP. Okay, same. If I go to the spine switch here, so IP PIM RP. What is showing that? Here you see that there is no star in a PIM, right? There is no star. It means these switches are client. You will see the spine switch has a star. It means this switch is a local RP. Okay, this is all we need. And you want to check the RP, so IP mroute. You will see that. So this is the discovery message from the interface 1 and 2, interface 1 and 2, and you will see that from this 1 and 2 we have got the IP, we have got the source address saying that it's a 1/2. This is the loopback address I'm coming, and this is the from leaf 2, 2/2. If you're coming from these two interfaces, okay, so it means spine 1 has information about loopback address of the leaf 1 and leaf 2. Okay, if any traffic coming going to come from the leaf switches, suppose let's say leaf 1, I'm going to configure interface loopback 1 IP address. I'm going to run like 40.1.1.1/24 IP route OSPF 1 area 0 IP PIM is password. Okay, the moment you run that command, you will see that spine switch will get this detail. The moment you enable the sparse mode, you will get that details. Make sure if this route is not present on OSPF database of the spine switch, this route will not be installed. Okay, you see that after some time, you have to probably initiate the traffic. So if I try to ping like 30.1.1.1, it's pinging. Let's go here. It may take time, but eventually it will come here. Okay. Okay. So this is the running the PIM. I will show that once it will sync. Okay. This is the PIM. So now PIM is enabled, multicast is enabled. Now this now time to enable the Vxlan. So there is two feature to enable the L2 Vxlan. We are not touching any L3 Vxlan. Okay, we are touching only flood and learn Vxlan. We have to enable two feature Vxlan feature Vx and Vxlan segment. This will enable, this will allow your switch to create VLAN segment and map your VLAN to the Vxlan. And this feature will enable your overlay feature in your for your Vxlan. NB means Vxlan here. Okay, so if you see here, and this feature will be run on the leaf 1 and 2. There is no feature on the spine switches. Okay, if I go here on the leaf switches, so run feature. So run feature, you see that I have mode, Ospf. I have these two features also. Okay, you just don't have to do a feature. I show here NV, sorry, VN. VN means Vxlan, this, and just like sim Ospf overlay. Okay, if I say so run pipe include feature, you will see that all the feature. Okay, this feature. Now, once the feature is enabled, you have to map that Vxlan. So I'm going to map VLAN 1000 to Vxlan 5001, right? You just simply do that VLAN 1000 and VN segment 5001, right? Now you can give name also, like for tribe something, anything, or if you want to do VLAN 2000 VN segment, like 6000, suppose, right? Now I have created two VLAN with a two segment ID. So so VLAN, so Vxlan. If you see that, so Vxlan, you will see that two mapping here. Okay, one is 200 with the 6000 mapped, and one is 1000 with the 500 map. Okay. Now if I have one more created, I think before that's showing one. Okay. Now if I go to the switch to, I have already created. So Vxlan. If I see here, it must have the mapping. So if you see the 1000 map with the 5001, okay, this is already there. Now we have to create the tunnel interface. You have to create the tunnel interface or Vxlan interface, virtual interface. Okay, this interface is a logical interface, will be responsible for your encapsulation and decapsulation. If you see the NV interface, NV interface means interface Vxlan 1. Okay, just like that. And source interface, I'm going to give as a loopback 0. Okay, then I'm going to say that this Vxlan tunnel will associate with the 5001 VNID and 5001 VNID associated with the 1000 VLAN. If any traffic from the 1000 VLAN is coming, it will convert to the Vxlan 5001. Then it will go for the Vxlan tunnel. Then it will check the member and it will check the multicast address. That's it. So if I go here and configure this, for example, okay, I go here, it's already configured for, I'm already configuring it. Interface NV1, no shut, source interface, loop back to example 0. If you want to keep 1, that's also fine. Let's keep 1 because I have created 1, right? NV interface shutdown before, oh, that's okay. No shut. Then I'm going to give member VN, member VN, member VN 5001. You can see that. Okay, 5001. So I have multiple 5001. I have multiple members. Member VNI 6000, right? Then I'm going to create here multicast. I'm saying that cast group, you belong to the 228.1. That's it. It's already configured. That's why it's not coming. Okay. So this is the this command. You just run it, and if you say that exit, so run. This is the command. Okay, it's already there. This is already there. So I have two interface, two VNID 1000 10, 5,000. Then I have 6,000. 6,000 is not participating in any multicast group. Okay, so make sure. Now, same thing we have in leaf 2 also. So run. Sorry. Okay, this is the Vxlan configuration. Segmentation feature is enabled, and we have this segment ID. This is 1,000 VLAN. Is converted to the 5,001. Now, once the terminal is everything is up here, this configuration is now up. Discovery process will happen. Make sure before discovery you must have the Jumbo L2 Jumbo MTU frame. Okay. If I say here, I have already configured that. So system Jumbo MTU. So Jumbo MTU. And this will come into the uh, so I check that. So okay, now once you've enabled that, you must have system Jumbo MPU 9216. This command will be run for the all the switches in the environment wherever you have, including the spine switches. Okay, because it's not necessary to have this Jumbo MPU because in spine switch just the layer 3 switch, but still it's always recommended to have end-to-end Jumbo MTU for the traffic, for Vxlan traffic. This is for the L2 traffic. If you have L3 traffic, you have to enable the MTU, Jumbo MTU on L3 level, L3 interface level. Okay, this is the L2 traffic, flood and learn. That's why we have L2 Jumbo MTU. Okay, once this is done, let's go into the leaf one. We have to check the Vxlan whether Vxlan is up or not. So NVE interface is saying that okay, this interface state is up and it's a Vxlan encapsulation. This is the data plane. Data plane means flood and learn. If it is a control plane, it means EBP and MPBGP, which is running with the Vxlan. Okay, and source address is this one. Source address is this one. If I say here, so NVE VNI, see that what is saying that we have two up and running VNI, which is L2, which is L2. And this is the Vxlan ID. This is the VLAN ID. This is the VLAN ID. Bridge domain BD is the VLAN ID. Okay. Now, same thing. If I go to leaf switches here, so NB interface is up and running. It's fine. Like I say, so NB VE in VNI. This is the just in a leaf 2. We have just one VN ID. If I go so and we so one so interface sorry so interface NV1, you will see that all these things we have Jumbo MTU now automatically enabled. The moment you enable the system Jumbo, you will see that MTU is affecting here. You will see that all the TX and RX ring, how many packets are sending. So what is happening if I say here, so NVE peers peer, if I say details, sorry, VNI. As of now, if I say here, so NVE adjacency, I don't see you will see the adjacency, but rather you will see that interfaces are up and If I say here, no, it will not become here by default. So our tunnel is fine, up and running between them. Now the next step is to associate these interfaces under the VLAN 1000 and configure these devices as a 1.1.1 subnet. I have not configured anything on these switches. Let me open this legacy switch 10/0 should be trunk towards the spine switch. If I say enable config T interface gig 0/0 switch port mode trunk encapsulation, I would say .1q. Yeah. Switch port mode trunk, no shut, VLAN 1000, interface gig 0/0, switch port mode trunk allowed, switch port trunk allowed, VLAN on. Okay, no shut. I'm going to the leaf 2. On the leaf 2, this interface must be trunk port, right? 0/1. I go here, interface Ethernet 1/2 port, switch port mode access, switch port mode trunk, switch port trunk allowed, VLAN all. I'm going to say, okay. Now on the legacy switch, this device should be the access port with the one VLAN for 1000 VLAN. So gig 0/1 uh, interface gig 0/1 switch port mode access, switch port access VLAN 1000. Okay, then I would say no shut, do show VLAN. You have the two interfaces which are associated with the 1001. So 1000 VLAN has 0/1, which is allowed. If I say here, so to show interface status, you will see the one interface is trunk, one is access port, okay, which are connected. Now, if I go to these switches 1/3, 1/3 must be the access port. Okay, so run interface Ethernet 1/3 access port. Okay, similar way here. So run interface Ethernet 1/3 access port. Now let's go to these switches devices and configure the IP address. I'm configure client as .1 and then .2 and .3. Okay, so let's see .1 IP 1.1.1.1/24 gateway. I will give just random 254. Okay. Similarly, I'm going to give server IP IP 1.1.1.2/24, then 1.1.1.254. Then I'm going to give this PC. PC is still not up. We bring it up. Let's try to ping between server and client. Okay. If I ping from client 1.1.1.2, look here. There is no 1.1. Subnet. This communication is happening based on the L2. Based on the L2. If I go to the switches, so IP route, there is no 1.1. Right? Nothing is present regarding the 1.1. This all the communication is happening through the L2 network here. If I trace route, trace 1.1.1.2, what is showing that? Destination is unreachable. It means ping is not working. This all the communication is happening through the R. Okay, so if I go to the leaf 1 here, so MAC address table VNI 5001, right? But you see that you have the MAC address from VNI 1, which is 20.1.1, which is your neighbor device, as well as MAC address from 1/3. Okay, so VNI 1 MAC address of one neighbor device, as well as the local address, which is directly connected, which is part of the 5001. Okay, similarly vice versa will be happen. So MAC address table VNI 5001, you will see that 1/3 interface and 1/4 also, because this switch has two interface for Vxlan. 1/4, which belongs to the VLAN 1000. VLAN 1000 is converted to 5001 VNID, and second is 1/3, which is server connecting. Third interface is NVE interface, virtual tunnel interface. Look here, and this is the leaf 1 IP address. If I see here leaf 1, so IP interface brief, you will see that 10.1.1, right? If I go to this router, let's configure IP 1.1.1.3 3/24. Now if I try to ping from here to here using 1.1, there is no IP 1.1. All the things going to be flood and learn based. Okay, now if I go to this server, ping 1.1.1, look here, ping is working fine, right? Ping is working fine. If I go to the spine switch here, so MAC address table, that's in there. There is no MAC address. It means there is no traffic is not going itself from the spine switch. Traffic is bypassing from the tunnel between here to there, because there is no MAC address detail here. Okay, if I show here, so IP PIM mroute, so IP mroute, why 40.40.1 is not coming? Because 40.1.1 is not initiating any traffic from the leaf 1. From leaf 1, I say yes, so IP interface brief 40.1.1 is not associating any traffic. Now if I go, so run interface and NVE1, if I change from 0 to loopback 1, then spine switch will see that, okay, 40.1.1 is now up and sending the traffic. Okay, if I do it now, so if I interface loopback 1, shut down first, interface NVE1, the moment I shut down this NV interface, if I try to ping from here to there, let's see. Just give me a second. Which interface has shut down? No, sorry. No, I haven't shut down. Okay. Now, if I go to ping now, look here. Ping here is timing out. It means traffic is not able to bypass, or tunnel traffic is coming here, but tunnel is dropping because tunnel is down. If I go to the leaf switch 2, 1, I say show interface NV1. Look here, interface is down. It means server itself not able to communicate. Server and client unable to communicate with each other. Okay. Now, if I go to the leaf 1 and say that, okay, interface NVE1, no source interface, loopback 0, source interface loopback 1, right? Then we say no shut. Okay, exit by show run interface NV1. You will see the loopback 1 is here. Now, if I try to initiate the traffic, ping at 30.1.1.1, ping is working fine. Now, if I go to spine switch was not showing the 40.40, right? Now, if I say here, router ID is still there. So IP pin PIM, if I say uh, event history, history for join prone summary, nothing is coming. Look here, what is saying that all the debugs. So you can say that how PIM is working. Traffic is coming from leaf 2 saying that I have this group ID. Okay, this is sending and this is this is receiving. Now from this switch saying that okay, I got this sending back. Stop sending, I registered your information. So this all the information are coming to this. Okay. If I see here now interface is up. Let's try to ping again. Let's try to ping. Sorry, what I configured here 3.24. Client is down seems. Oh, client having issue. So let me restart this and start again. So this is the all about the Vxlan concept here. So it seems like having some issue with my virtual machine. Started. Okay, let me configure that IP1.1.1/24. If I try to ping from server from legacy network, it should reachable. What happened to this client? That's okay. To ping. This is reachable. Why? Okay, so if I try to ping from ping 1.1.1.2, so that seems like having issue with this virtual machine. I don't know what's wrong with it. Okay, so this was the Vxlan or data plane lab with the concept. So this is pretty much simple. You need to understand first underlay. Once you have the underlay information, overlay going to be easy because and this is just data plane learning. And for the control plane learning, stay tuned. We will posting the Vxlan control plane MPPG PVPN lab very soon. Thank you for watching.